We have here a very useful formula, change of base formula. And your calculator, if you have a cheap calculator, at least does, probably, if it has logarithms, it has base 10. And it probably has base e too, but I know it has base 10 because that's what we assume. So let's say that you have to find the log base a. I don't care what a is. The only thing is it's not 10, okay? So you get to use, in the formula, you get to use log base 10 for both of them, so your calculator can handle this. And what you do is you say, I'm going to put the desired results on top, so I'm going to take my new log base 10 of the desired result over the log base 10, happily, of the base, okay? So it's the desired result over the base with the logarithm that I can handle, x to the 10. So, or x to the 10, x base 10, log base 10 is what I'm trying to say. Anyway, so it's super useful. And here you see my calculator doesn't like the idea of log base 4, but it likes log base 10. In fact, it assumes it. If I say log, I'm assuming, I don't have to write the 10 here, I assume it's 10. So I just say log 25, that's what I was supposed to get, 25, over the log of the old base, which is 4, and it spits out the answer. And same thing here, if it's log base 2, I don't care. It also works if you try, it also works if you try with a natural log, log base e. You say, I don't want log base 4. Okay, fine. Log base e of the desired result, 25, over log base e of the old base, which was 4. The old base is 4. Okay, and that's it. That's it. So we change the base here. And so what we're going to say here is this is equal to log, I'm assuming base 10 of 7 over log base 10 of 3, sorry. And then we're going to say again, we're going to say log base 10 of 4 over the log of 1/2. Okay, I'm going to put this one over here. We're going to say the log base 10 of, I was looking at something for a second, 0.9 over the log base 10 of my old base, 6. And then here I have, I don't think I need that arrow, is equal to log base 10 of, I was thinking about doing a natural log. You know, it doesn't matter which one I use. The natural log of 1460 over the natural log of the old base. Okay? So let me go ahead and actually do this. So my calculator likes to assume things. It assumes, I have to find the log key. Okay. It's 7, and that's 0.84. The log of 3, that's 0.7477, and I divide and I get 1.77. How many places? To 3 decimal places. I need one more. Okay, that's the first one. And then 4, base 10 log, and then 0.5, base 10 log. And so I get, that's a negative because I get something less than 10, obviously. This has to be a negative because I can't have 10 to the 0. That'd be 1. This is less than 1. It's 1/2. So anyhow, I divide, and I get -2. Isn't that nice? -2, 0, 0, 0. Nice and even. And I mean, I could think about that. Think about that for a second with me. Your base is 1/2. You see that? Your base is 1/2. And I raise that to the -2. That's going to be 2 to the 2, which is 4. So that makes perfect sense. Okay, so what do we get here for 0.9? We do the log of that. That's less than 0 as well. and then I say the log of 6, and I divide, and I get another negative, and that's going to give me negative 0.05. I round to 9. Okay, and then this one, what's this one going to give me? I'm going to say the natural log, 1460, natural log of that, 7.286, divided by the natural log of 15, and that's going to give me 2.69 round to 1. There we go. And you say 15 to the 2 would be 225, and 15 to the 3 would be, what would that be? 15 to the third power is 3,375. So the fact that that is right between makes good sense. 2.6, instead of 2, instead of 3, it's 2.69. Okay, sure, I can see that.